We're going to start talking about making predictions when you have a line of best fit. So this is assuming you have a line of best fit, which we do have on this graph here. We are going to try to use that graph to kind of answer some questions about it. All right, so let's look at what the question's asking us to do. So it says the scatter plot shows the number of hours worked X, so that's right down here, and the amount of money spent on entertainment Y. So here we are back to kids with jobs wanting to spend their money on movies and things like that, by each of 25 students. All right, so this is 25 X's up on here, and then there's a scatter plot that goes through it. So using this equation of the line, so it gives us an equation. All right, now if you guys remember, this y equals 1.84x plus 11.32. This is a line that is in slope-intercept form. So your slope is 1.84, all right, that would be your slope, okay? And then this 11.32 is your y-intercept, right? That's what y equals mx plus b. So m is your slope, and your slope is 1.84 because that's the number that's in front of the x when it's in this form. And then plus b, b is always your y-intercept. So what that means is this line, if we extended it all the way out, would cross the y-axis at 11.32. Okay, it's a very exact official number there, but it crosses, you know, above 11 and below 12. All right, so when it asks us questions about this, we got to think exactly about what that means. So for letter A, it says, what is the predicted amount of money spent on entertainment for a student who doesn't work any hours? So what they're saying, the amount of hours worked is your X, right? So if I made this 0, what would I get for my Y? What would what would that be? Well, think about it. If you put 0 in, you're going to get rid of this term. Okay? And if you get rid of this term, all you're left with is this right here, is this 11.32. Well, that also happens to be where it crosses the y-axis. And if you look at where the y-axis, what the x is on the y-axis, x is 0. That's where the y-axis is. The y-axis is where x is equal to 0. So your y-intercept is always going to be the number that you get when you put 0 in for x. So it's kind of like two ways of saying the same thing, right? So the projected amount of money spent on an entertainment for a student who doesn't work any hours is going to be your y-intercept. So it's going to be 11.32 because that's where it crosses the y-axis. And the y-axis represents the amount of money spent on entertainment. All right, so 11.32. And then letter B, it says, for an increase of 1 hour in time work, what is the predicted increase in the amount of money spent on entertainment? So hard concept for a lot of people to understand, but that is always your unit rate. And unit rate in these types of problems is the exact same thing as your slope. Your slope says that if you put 1 in, it's going to be 1 times this 1.84. If you put 2 in for your slope, it's 2 times this. So you're always multiplying by a factor of 1.84 for every extra number of hours worked, right? For your hours number worked. If you work 5 hours, it's 5 times this number. If you work 10 hours, it's 10 times this number. So if you just work 1 hour and every hour it goes up, it's going to just be one of these. So the answer to these is always just your slope. So if you can identify what your slope is, it'll be 1.84. So for an increase, 1 hour in time work, the predicted increase in the amount of money spent on entertainment, it means that for every extra hour they work, we could predict that they'll spend an additional $1.84 on entertainment. Okay? And then for letter C, it says, what's the predicted amount of money spent on entertainment for a student who works 8 hours? So for this, it's very easy to look at 8 here and go up and then just kind of guess. But what they want you to do is they want you to physically put 8 into this equation and figure it out. And so all you have to do is recognize that the amount of numbers hours worked is your x. So if I substitute 8 in for x and just put that in the calculator, we should be able to figure this out. So let's do that. So let's go 1.84, and then it would be times your x, and your x is 8 hours. And then we add 11.32. So all I'm doing is I'm just plugging in this equation right here, and I'm substituting in the number they're giving me as x for x. All right, so I put the 8 in right there. That's where x goes. And then I would just hit equals and let the calculator figure it out. If you're going to think of order of operations, you would multiply 8 times 1.84. So this should be probably around 14 or 15 right here, and then plus another 11. So our answer should be, I don't know, 25, 26, 27, around there. Let's see what it gives us. Yeah, 26.04. Very good. I like to estimate where I think things are going to be so that I can check the reasonableness of my answer when I get it later. And if I get something that's kind of crazy, I can go back and look at it and make sure I did it right. So let's see if ALEKS likes what we did. Oh, look at that. It loves it. Great. Let's do another one. Okay, scatter plot shows the time spent texting X and the time spent exercising Y. So if we look at this, basically it means that the more you text, the less you exercise. All right? So that seems pretty drastic, but that's what this graph is showing. All right? And their sample population that they used. All right, so now they're giving us an equation again. So you can tell because it goes down, it has a negative slope, 0.73. So remember, that's your unit rate, okay? And then this point, this positive 8.53 is where it crosses the y-axis. And remember, where it crosses the y-axis is where your x is 0. So for this first question, what is the predicted time spent exercising for a student who spends 4 hours texting? Ooh, they're switching it up on us. So instead of finding what I thought we were going to do, we're going to actually go right away to substituting this 4 in the equation to see what we got. All right, so let's take 4 and let's put it in the equation. So get out your calculator and we'll put in negative. All right, let's try that again. Negative 0.73 times, and then we're going to put in 4 because that's the value we're putting in for x. That's time spent texting is your x times 4, and then plus 8.53. And if I did this right, this should give me like, I don't know, negative 3, maybe 5.5, 5.5 or so. Yeah, 5.61, not too shabby. That looks reasonable. All right, B, what's the predicted time spent exercising for a student who doesn't spend any time texting? Well, if you don't text, that puts you at 0 hours, and that means wherever this line crosses right even with here. Well, we can get that from the equation because that's your y-intercept. So it's going to be this number right here, 8.53. So predicted time is about 8.5 hours exercising for a student who doesn't text at all. So they're saying here that, you know, the less you text, the more you exercise. The more you text, the less you exercise. It's a negative relationship, right? C, for an increase of 1 hour in the time spent texting, what is the predicted decrease in the time spent exercising? Remember, they are asking us here for the unit rate. What happens every hour? Well, every hour it goes down this amount, all right? So for an increase in 1 hour time, the predicted decrease is 0.73, all right? Let's check it. Look at that. All right, good luck with these. These are worded a little weird and a little hard to understand, but I think you guys got this.